Hi, in this module, we're going to learn about programming. We most often have heard enough of this word. I can't wait to get very familiar with it. Let's get right into it. What is computer programming? Computer programming refers to the process of telling a computer which tasks to perform in order to solve problems. You can think of it as a collaboration between humans and computers, in which humans create instructions for a computer to follow in a language that the computer understands. A program is a step-by-step instruction or guide given to a computer on how to execute a task or solve a problem. Note that the terms program, software, algorithm all have almost the same definition and sometimes are used interchangeably. It is because they all technically refer to the same thing, a set of instructions, but in different volumes and context. Writing a program is just like outlining a step-by-step instruction on how to achieve a solution or perform a task. This instruction, if executed exactly in the same order and format, with the same parameters, the same result is guaranteed. Let us take, for instance, a step-by-step guide to prepare a meal or bake a cake. The first step is to outline the items needed to bake the cake, of which in our case, we have 1 cup of cake flour, 1/2 cup of sugar, 10 eggs at room temperature, 1/4 spoon of cream of tartar, 1/4 teaspoon of salt, 1 teaspoon of vanilla extract, 1/4 teaspoon of almond extract, 1/3 cup confectioner's sugar for top of cake. Following the steps outlined at the left side of our slide, we can be able to achieve the cake on the right side. While small alterations in amount or certain other conditions might alter results slightly, the final solution is very much similar. This idea is the same in programming. In fact, programming is a perfect and most widely used of that concept because of the automation of the process by the computer. In computer science, we can represent a program using a simplified structural format known as flowchart, or its loose functional equivalent called pseudocode. Let's learn a little about how these techniques work and see an example of how they can be used. What is a flowchart? A flowchart is a graphical representation of the procedure for writing a program to solve a certain task. Flowcharts are written with program flow from the top of the page to the bottom. Each command is placed in a box of the appropriate shape, and arrows are used to direct program flow. We will learn a bit about this structure and so therefore use them to represent our own program. Pseudocode is a method of describing a program using a combination of natural language and programming language. It is essentially an intermediate step towards the development of the actual code. It allows the programmer to formulate their thoughts on the organization and sequence of a computer algorithm without the need for actually following the exact coding syntax. Although pseudocode is frequently used, there are no set of rules for its exact implementation. Flowchart symbols include terminal. This indicates the starting and ending of a program. We have the decision, used for asking questions that can have a true or false answer. Connector, used to connect bricks in a flowchart. Process indicates an internal operation like initialization, calculations, etc. Control flow, used to show the direction of the flow of the program. Input/output or I/O, used for input and output operations. Let us look at an algorithm to add 5 numbers. First, we set variable sum equal to 0, which is a process, an initialization process. We set variable count to 0, which is also an initialization process. We prompt the user to enter the value of n, which is an I/O process. We add the value of n to sum and store the value in sum. We add 1 to the value of count and store the value in count. We check if count is equal to 5. If this is true, we'll print the sum. If false, we'll go to step 3. And finally, we halt the program. The flowchart implementation at the right goes as follows. Now that is how we can be able to achieve an illustration of our program using flowcharts. Let us look at pseudocode. For pseudocode, no standard for pseudocode exists. so we don't have to follow any strict syntax like computer programming languages. Pseudocode can vary in style from author to author. Pseudocode commonly borrows its syntax from popular programming languages like C, Pascal, Fortran, etc. So we'll make up our own rules based on the following Fortran principles. The usual Fortran symbols are used for arithmetic operations: addition symbol, subtraction symbol, multiplication symbol, division symbol, and the raised to power symbol. Symbolic names are used to indicate the quantities being processed. Certain Fortran keywords can be used, such as print, read, write, etc. Indentation should be used to indicate branches and loops of instructions. Let us look at the same algorithm using pseudocode this time. First, we set variable sum equal to 0. We set variable count equal to 0. We'll prompt the user to enter the value of n. We'll add the value of n to sum and store the result in sum. We'll increment count by 1 and store the value in count. We'll check if count is equal to 5. If true, we'll print the sum. If false, we'll go to step 3. And finally, we'll halt the program. The following pseudocode instructions are generated. This is how we can be able to solve this problem using pseudocode. We have various programming languages such as the C programming, the C#, Python, PHP, JavaScript, so on and so forth. And these languages are tailored to create or develop programs. Some key features of these programming languages include the syntax, the specific rules and structure used to write code in a programming language, data types, the types of values that can be stored in a program, such as numbers, strings, and booleans, variables, named memory locations that can store values, operators, symbols used to perform operations on values such as addition, subtraction, and comparison, control structures, statements used to control the flow of a program, such as if-else statements, loops, and function calls, libraries and frameworks, collection of pre-written code that can be used to perform common tasks and speed up development, paradigms, the programming style or philosophy used in the language, such as procedural, object-oriented, or functional. In the next video, we'll delve into programming languages such as C++, C#, JavaScript, and PHP. These are the programming languages that I'll be using throughout this course. So I'm going to be teaching the languages so that we can be very well oriented when learning how to use these languages to create application. Introduction to Programming was brought to you by Oguchibweze from Beaverbank Technologies. You can follow me on all my social media handles. Thanks for watching, and I will see you in the next one.